It's Larry, W6WUH in California. So what we did today was test all of the tubes in the T-102 transmitter, and made a note of their condition, gain, output, whether or not the emission was good, if they were gassy or had shorts, da-da-da-da-da. So we found a couple of tubes with a couple of weak sections that probably, given what they do, like in this case a relay amp, we know it's still working. And this one's not good. This is a balanced mixer. So we got 4 12AT7s in here. We've got 2 really good ones. We've got 1 quite good one, and we got 1 crummy one. Unfortunately, one of the crummy ones is in the second balanced mixer. So we're just testing it right now with the tubes the way they're in it, because we know it works. And we want to get a little better assessment of how it works and kind of get used to tuning it up and operating it. Before we swap any tubes around, I'd like to put the 2 best 12AT7s in the balanced mixer, but I'll have to realign the transmitter when they do that. But anyway, thought we would give this thing a go. We got it hooked up to the watt meter and the dummy load. I have had a cooling fan on this power supply because it just gets so hot right away. I measured the filament voltage across the dial lights, and it's nearly 8 volts, which is just too damn high. And I haven't measured the other voltages because they were close enough. But when you modulate this thing and it draws some power, the dial lights dim, which is pretty peculiar. So anyway, I'm going to let you listen to it, and you can see what's wrong with it, I guess. Well, I don't know. Let me just do it this way. I'll hold the stupid thing. You can... W6WUH on the dummy load. Hello, 1, 2. So you can hear it's got a good deal of hum. And so that's those bad paper capacitors in there. And the first audio tube, the mic amp and speech amp, that tube has got low emission and it's gassy. It's just on its way out. So we will replace that tube for sure. And we'll put the new electrolytics in the audio section there and see if we can't get rid of that hum, because that just sucks. Anyway, there we are. That's lower sideband, 1, 2, 3, 4. Go over here and change this thing to same frequency, upper sideband. So you can see that it has shifted some. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. So if it was aligned right, the carrier oscillators were set right, and the balanced modulators were all set right, and everything was right, you should be able to change between upper and lower sideband and not have the carrier frequency shift any. So that part ain't right. The other thing I'm seeing here is that when this thing is in the tune mode and even making 100 watts of output. The plate meter is pegged. Let's see if we can do it here. I'll just set this thing for 100 watts. Okay, that's 100 watts of carrier output, and the plate meter is just absolutely pegged. Looking at the Collins and stuff, they make about 130 watts power in the CW mode, and this will make at least that, maybe more. But either the meter resistor is taken a walk and gone off the reservation, and something isn't right. I'm going to take this thing with no mic gain at all, and we're going to see what the plate current does. I think that's supposed to be 37 milliamps. I'm going to have to look in the manual. I guess this is 20, 40, 60. So that's just under 40. So that's probably set about right. Okay, I'm recording. I'll be in a minute. The other thing that's peculiar is if you are reading the grid drive, well, let's go back up to, we'll set this thing up for 100 watts. Okay, now we'll look at the grid drive. It's barely showing any grid drive there. I haven't got enough hands to do this, but I'm thinking that the grid drive should be something, you know, like that, like about 5 mils or something of grid drive, and that drives the output up to 150 watts. Hello, 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 hello. So I don't know. I've got to figure out what's going on. I've got to read the manual, but I suspect something is not quite right here, and I just don't know what it is yet. W6WUH. So what I did today was I took out one really weak and gassy tube in the audio section, and one tube that was weak and not very well balanced in the second balance modulator. And I took the two very best 12 AT7s I had and moved them into the first and second balance mixer. And I took a new tube, or apparently a new tube, unboxed, but it tests new tube, and I put that in the carrier oscillator. Really well balanced and full emission. Put that in the carrier oscillator. I took one of the good 12 AT7s and put it in the Vox. The Vox had a perfect brand new tube in it, but it didn't need that good a tube in there, so I put a very good used one in there. And so now every tube in the thing is either tests 90 or 100%, or if it's a diode, it tests okay. So no weak tubes in there anymore. Well, let's see. I guess the relay and tone amp might still have kind of a dodgy 628. The triode section is down to 67%, but it's working all right. That just that powers the push-to-talk relay. So if the push-to-talk gets dicey, then I know what to do. So anyway, it still hums. But not as much as it did. Let's see. W6WUH. Hello. 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 1 2 1 2 1 2. Hello, 1 2. So there it is. Didn't seem to upset the carrier balance in here any, so surprisingly. So now that we've got the best tubes we can have in it, I'll go through the alignment procedure. I got to get out the RF voltmeter probe for the VTVM, and we'll try doing it alternately with that way, and perhaps with the scope, if the scope has got a limit on the high voltage that it can accept of, what's it say, 300 volts max. So I think there's only half a volt of RF there, and so if there's not also B plus there that I need to worry about, maybe I can put a blocking cap in there. We'll try it with the scope also, but we'll do it the way the book says with the RF probe. Should be good enough. And see if we can get this guy. I got to recap it first, and then we'll do the alignment. But I think maybe only one of those paper caps might be in the carrier oscillator or the band oscillator, but all the rest of the stuff is, you know, in the Vox circuit, the audio circuit, the keying circuit. Is not RF stages, and changing the caps won't change anything at all. So this is the current draw with this thing in the standby mode. 75 watts, and I think it was about 75 watts with no load on the power supply. So this thing is drawing 75 watts just sitting here, plus the bleeder resistance. So I'll have to think about whether or not that's right. And hello, 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 hello. So about 450 watts on peak, something like that is what it's drawing.